Good afternoon, everybody. Let's solve dilution questions together that were in your notes. So hopefully you're watching this video after you've tried to solve them on your own. So we've already answered number one together. We have concluded that it was 0.324 liters or 324 milliliters. Let's take a look at number two. A lab technician would like to dilute a 3% MV solution of sodium chloride, NaCl. She takes 250 ml of a concentrated sodium chloride and adds water to prepare 1.5 liters of the diluted solution. What is the concentration of the new solution in percentage? So for that, right away, like I suggested before, start with what you are looking for. What is the concentration? So I put a question mark at C2 because they're asking the new solution. So automatically that means that leaves us with 3% that I can place over here in C1. Then I have, it says, she takes 250 milliliters of the concentrated sodium chloride and adds water to prepare 1.5 liter. So 250 ml is my initial volume right over here, which I already put in liters. And she adds water and gets at the end a 1.5 liter solution. So that's what I write down at V2. Once you've established this information, you use the formula C1 times V1 equals C2 times V2. And you plug in your information. Even that, you can leave it in percentage, it's fine. 3% times 0.25 liters equal C2 that I'm looking for times V2, which is 1.5 liters. Then you solve 3 times 0.25 is 0.75. Oops. Percent liter equals C2 times 1.5 liters. Divide by 1.5, so 0.75 percent liter divided by 1.5 liter. The liters cancel, as you see here. These two cancel, and you end up with 0.75 divided by 1.5 equal 0.5%. Because this liter cancels and this liter cancels. You get 0.5%. Number 3 we solved in class together, and we concluded that A was 0.6 grams of the salt, and Maria adds 50 milliliters of her original solution. So we concluded that the answer for that one was 6 grams per liter. Let's go to number 4, as that's a newer question. You add 400 milliliters of water to 200 milliliters of a 3 gram per liter solution of hydrogen peroxide. Calculate the new concentration. Right away, you see that? Calculate the new concentration. So I put an X or a question mark as C2. Then it says, and then we have 3 grams per liter. So that's my other C1, the other concentration. So 3 grams per liter. Then it says you add 400 ml of water to 200 ml. So this means I had 200 and I added 400 to it. So starting off with 200 ml, that's why I wrote it as V1. And V2 is now the total 400 plus 200 is 600 milliliters or 0.6 liters. Okay, now that we've established all that, we can easily use the formula C1 times V1 equals C2 times V2. And I'm going to replace my values. 3 times 0.2 equal x times 0.6 divide by 0.6. You end up with 1 gram per liter is C2. And then you verify, like pay attention to the values. Is my second concentration lower than my first concentration? Then yes, this makes sense. It is lower. I have added water, so my second concentration is lower. And at the same token, we can look at the volume. Volume 1 is indeed smaller than volume 3. So I did have less water in the beginning. That's why it's so concentrated. And I added more water. My last volume is higher. Okay, guys, number 5 now. We're asking number 5, what volume of 6 gram per liter acid is required in the preparation of 100 milliliter 1 gram per liter acid. So it's asking, again, what volume, so it has to be a V1 or V2, is required in the preparation of 100 milliliters 1 gram per liter. So notice we're talking about, we're preparing it. We want this as our end result. We want the 100 ml as our end result and the 1 gram per liter as our end result, our final situation. So this is where I can write down these two under the second situation, which is 1 gram per liter would be C2 and 100 ml would be V2. Again, taking care, looking at the volume, just erase that. The volume here is 0.1 liters, okay? And it says 6 gram per liter is my starting point. 6 gram per liter comes here, C1. And now I need to know how much V1 did I have at the beginning. Okay. So once you've established that, once again, use the formula C1 times V1 equals C2 times V2. And I'm going to add my information. 6 times X equal 1 times 0.1. And then you solve for X, divide by 6. And you end up with 0.0167 liters or 16.7 milliliters. Next question, you are given a 1 gram per liter solution of KOH or potassium hydroxide. Using this solution, you must prepare 100 ml of a diluted solution that will have, you see the future here, will have a concentration of 0.25 gram per liter. Just bring that down. Question A says, what volume of the initial solution should be used? So let's start. Let's see. Remember what I told you, the trick? The second concentration must always be lower than the first concentration. So you see, I have two numbers here, 0.25 and 1. So then I can safely write 1 for C1 and 0.25 gram per liter for C2. All right, now next is this information. You're using the solution, you must prepare. This is what I need to get. This is my final situation. So this is where I'm going to write the 100 ml. I'll write it over here, except this one's in liters right away, 0.1 liters. Okay. Now it's clear. It says what volume of the initial solution should be used. So I'm looking for V1. As a matter of fact, I could have started with that, like I said previously. If it said what volume of the initial solution, I'm looking for V1. And the rest you solve for V1. So that 1x equal 0.25 times 0.1, and x is 0.025 liters equal 25 ml. And a lot of times students ask me, do we have to convert it in milliliters? No, we don't have to unless we specifically ask you. I like to put in milliliters. It's easier with calculations and like visualization, but it is not necessary. For example, with the next question, it says, how much water should be added? So to go from the initial volume to the second volume, the question basically says, how much water did I add to get from V1 to V2? That's why I did 100 ml minus 25 ml equal 75 milliliters. But if you did all of that in liters, then that would be 0.1 minus 0.025, and you would get 0.075 liters. And that's it. Here's like one last screenshot of the answers. See you later.